If a client's ever asked you what sample size they need for their study, then this video is for you. In this video, I'll be talking about statistical power and its relationship to sample size and what you should bring to the table in order to be able to estimate the sample size that your client needs for their study. So to set the stage for this video, I'm making two assumptions. The first is that the study in question is trying to estimate the impact of some sort of program or intervention or treatment on a quantitative outcome. So for example, you may be helping a client trying to evaluate the impact of an educational intervention on students' literacy skills. And literacy skills are being quantified by some sort of score on an assessment. Another assumption that I'm making is that you're in the early planning stages of the study and you're trying to figure out what sort of sample size that you need. So what is statistical power? So I'm going to loosely define it as the probability of detecting an effect when it really exists. So what I mean by detecting an effect is, let's sort of fast forward. You've done this study, you have some sort of result, and you find that there is in fact a difference between the treatment group and the comparison group, and that difference is statistically significant. So you concluded that you did in fact detect the effect. So it's the probability of that happening when in reality the treatment does have an effect. It actually is effective. So based on that definition, it's clear that we want a lot of statistical power, right? We want a high probability that we detect an effect when it actually exists in real life. Your client probably assumes that the program is effective, and so you want a high likelihood of picking up that effect. And statistical power is a function of several things, including the significance level, which is often set at 0.05 or 5%. And what the significance level is it's the acceptable rate or probability that you're willing to accept that you may detect an effect when in real life it doesn't exist. So again, you fast forward, you've done your study, you collected your data, you did your analysis, you conduct your hypothesis test, and you detect an effect in the treatment group. You say, okay, the treatment group did better than the comparison group, but in real life there is no treatment effect. And so 0.05 in this context, it means that you have a 5% chance of that happening, that you detect an effect when in reality the effect does not exist. There is no real treatment effect for this intervention. Now, we can set the significance level to lower. Let's say we really don't want to make that kind of mistake. We can set it to 0.01. But the problem is that then it's harder to detect the effect, so you have less statistical power. And if you're more lenient with that significance level, then you're willing to accept a higher error rate for that kind of error where you detect an effect when it really doesn't exist. Let's say you set it to 0.1, then it's easier to detect the effect, so you have more statistical power. But again, common practice is to set it at 0.05. It doesn't have to be, but that's what's typically done. Statistical power also depends on the size of the effect. So if in reality the treatment that you're interested in has a huge effect on the outcome that you care about, then you are more likely to detect that effect in your study, and so your statistical power is higher. If in reality the size of the effect is very small, then you're less likely to detect that effect, so your statistical power is lower. Another factor that affects statistical power is sample size. So the more people you have in your study, or the larger your sample size, the more likely you are to detect an effect if one actually exists. The less people you have in your study, the less likely you are to detect an effect if one actually exists. So now that we've talked about statistical power and its relationship to things like significance level, the size of the effect, and sample size, how big of a sample size do you need? And the answer to that question is that it depends on those same factors. So, like statistical power's relationship to significance level, size of the effect, and sample size, if you want to calculate your sample size, you need to know these other factors. You can think about it like one big equation where to solve for one, you need to know the values for the other things. And so to be able to estimate sample size, you're going to need to be able to provide or settle on a few different numbers. One is the desired level of power that you want for the study. Typically, that number is set at a value around 0.8 or higher. So, you want the probability of detecting an effect when it actually exists to be, 80% or higher. And typically, the significance level is set at 0.05, like I said earlier. And the size of the effect is one that you usually have to go and track down. You want a reasonable number that is reflective of what you would expect for the treatment that you're studying. A good source for this sort of information to try to find out what is a plausible size of the effect, or what's commonly referred to as an effect size, is to go and track down research articles that have a similar treatment with a similar outcome, with a similar population, and that will give you a number that you can use for this purpose. Once you know all of these numbers, then you'll be able to estimate your sample size, and there are lots of tools out there that are available to help you do this. One of those tools is G-Power, and I'll bring that up so we can take a look at it. And so here I have a power calculator called G-Power, and there are a few different things that it needs as input for me to be able to estimate the sample size that I need. One of the things I need to know and provide is the sort of statistical test that I'll be doing. Right here, I'll just assume that I'm going to be using a basic independent samples t-test here, where I'm comparing two groups on their means to see if there's this treatment effect. And so, because that's what I anticipate doing in this study, for example. And then it says, well, okay, what do you want? And so typically what you will want is either to compute your required sample size, or you may want to know, that you've already got a fixed sample size that you're able to obtain. And so you want to be able to identify what's the effect size you'd be able to detect. So how I mentioned before, if you recall, I mentioned before that these different factors like power, sample size, effect size, etc., are all related to one another. This is basically allowing you to solve for one by specifying all the other things. And so right now I'm going to leave it at compute required sample size, because that's what I want to do in this hypothetical example. It's asking me for the effect size, which is a number that we'll be quantifying. I won't go into the details here, but for right now, I'll just say that is 0.5. We'll have the significance level at 0.05, and then power at, it just had 0.95 for a default here, so I'm leaving that there. And then it asks for allocation ratio, which in this case is one of the things that I need to provide. So that's just saying that your sample sizes for the treatment and comparison group will be the same, so the ratio will be 1 here. And then I hit calculate, and then it gives me the estimated total sample size of 210 people, 105 in the one group and then 105 in the other group. So there's an example of how to calculate or how to estimate sample size based on some of these factors that I mentioned. Now, there are a couple caveats to keep in mind whenever you're using some sort of a sample size or power calculator. One of the caveats is that you're always just getting an estimate of the sample size. And to the extent that the information that you provide that calculator are accurate, then the estimate of your sample size will be pretty accurate. To the extent that they are not, then they won't be. So make sure that you really rely on prior research and evidence to the extent that you can to inform the numbers that you put into one of these calculators. Another thing to keep in mind is that these calculators all make assumptions. In order for you to be able to simply plug in numbers and then get numbers numbers such as your estimated sample size, there are assumptions that are baked into these calculators, like the data behave like you expect them to, and that you won't have any missing data and that sort of thing. And because real life is often more complicated and real data are often more complicated and full of issues and challenges, um, don't assume that these numbers are sort of set in stone and accurate. And one of the things that you can do is to try to estimate like a range of sample sizes based on a few different conditions. Another thing that other people will do is to simulate data so that they can try to calculate the necessary sample size under more realistic assumptions that they anticipate.